So this is the next example. It's really the same as all the other ones. If you look at the textbook's making these seem a lot harder than they are. But we're just going to follow the first rule of solving limits, which is the first thing you always do, is plug in the x value they give you. So they give you x equals 0. So we're going to go the square root of 0 squared plus 4. And that's 2. So the limit as x approaches 0 is 2. And we're going to do the same thing on the right side. We're going to plug in 3. So we're going to do the cube root of 2 times 3 squared minus 10. So what's that? 3 squared? 9. 9 times 2, 18. 18 minus 10, 8. Cube root of 8, 2. And so we get 2. So the answer to both of these things is 2. So I think the only thing we'd have to make sure of is we'd have to make sure that it's approaching that from both sides. So like, for example, here, we should make sure, I guess, that like if we plug in -1, it's legit. Like we have to be able to plug in values on both sides and have it not be undefined. Like one example of where that would matter is if we had the limit as x approaches 0 of root x. Like I don't think that's 0. That's not equal to 0. Because the deal is, if you're trying to approach it from both sides, like if we plugged in numbers just to the left of 0, just less than 0, see how that's the square root of the negative, and that just breaks it. So the graph just like starts there at 0, so you can't just plug in 0 there. You have to make sure there's graph on both sides. But that'll happen here, right? Because there's never any undefined stuff. Because we got the cube root, that's never undefined. And we got the square root, but since you're doing x squared plus 4, that's always positive anyway. So these graphs are just always continuous. So I guess this applies. So the only time this doesn't apply is a situation like here, where the graph just starts at 0, and that's why it doesn't approach it from both sides. So the properties of the limit still have to work. But that, again, is such a rare thing. You just kind of have to think about it for a second. Make sure that the graph is not starting right where they want you to be looking.